Welcome to Code Intraster.
Hi everybody and welcome to this video on Bresenham circle. So in the last video we learned how to draw a line using Bresenham's parameter. Bresenham uses a parameter p. So in the similar way we have equations for circle, and p naught is calculated as 1 minus r. Actually it is 5 by 4 minus r. Since it is an integer, we kind of convert the float to integer, we get 1. So p naught is equal to 1 minus r. It's for integer. So when you kind of implement in the computer program, we want 1 minus r and not 5 by 4 minus r. P naught is over, and then we have a condition called p naught is less than 0, and then p naught is greater than 0. So when p naught is less than 0, we kind of increment, we always increment x, and then we keep y as such. And when p naught is greater than or equal to 0, we kind of increment x and then decrement y. You might ask me, in the line the line goes like this, so we kind of incrementing both x and y when p naught is greater than 0, greater than or equal to 0. So you might ask me, why in circle you need to decrement, and how about it just generates the whole circle? Lot of questions might arise right here, so I'm going to answer these questions through other diagrams. So this is a circle, and a circle can be divided into a number of octants, and there are about 8 octants in a circle, and Bresenham only deals about drawing this part of circle. So if we are able to draw this, we can replace part this part over here, over here, over here, and over here, and over here. Likewise, we can complete the whole circle. We do not need to calculate the points for these circles, these octants, right? So this algorithm is very efficient, that only this octant of the circle the points are calculated, right? So that's what you need to understand. Let's move on to the next diagram. And you might ask me why we are incrementing x and why we are decrementing y. So this image answers this question. As I told you that we are only considering to draw this octant, and then we are going to change all the points to the rest of the coordinates. Around remaining 7 octants, we are going to just place the value which was calculated for this octant. Alright, so it is that easy. You can visualize the octant to be like this over in the diagram. As the blue line, we are going to just draw this circle, and this is an octant of a circle which we are about to consider, right? And then as you see, the circle always increments in x-axis, so the curve goes like this. So we have xk plus 1, always xk plus 1. And you can check that in the y-axis we kind of decrement, and this is how, because and since we are drawing this octant, we are decrementing the y curve, and that's why we are deciding with p parameter whether to decrement y or keep it as such, in order to get this kind of curvy feature. Now you understand why we increment x and we decrement y. Now we need to understand the starting point is 0 comma r, the radius. For a circle, we have a radius and a center point. So we draw this octant starting from this point till it reaches this point. What does this line mean? This line where x is equal to y. So when such a condition is met, when x is equal to y, or in computation we just say when x is, let me come again, when x is greater than or equal to y. So it is similar, right? First x will be equal to y, then only it will be greater than y, right? So we kind of check this condition until this condition is met. We kind of repeat the whole loop in order to find all the pixels, not the points, all the pixels in between these two quadrants. All right, all the octants. All right. So we just calculate one octant and then we repeat it to the other 7 octants. Alright, let's move on to the program. My idea was to complete this video with less time so that it will be a quick revision during exam time. Right, so now we just include a set of library files: conio.h studio, the standard input output standard library, and then a graphics.h Borland graphics interface, as I already explained. And then here we have a declaration for circles. And why do we need declaration before main? So C program goes from top to bottom, reads the program from top to bottom. Alright, so it needs to know that a function exists after a main function. So the main function gets closed right here, and there is a circle plot point here. So we need to somehow tell the C program that there is a function which is implemented after main. If suppose you are implementing the circle, implementing it right here, you don't need this declaration. Alright, and then our C program starts from the main, and then we have the x center, y center, radius, deduct, gm, x, y, p. These are all the variables which we are going to use throughout the program. And initialize graph, just ask the computer to set all the drivers so that we can draw it on the screen. And the next line print asks for a center point and a radius. In order to draw a circle, we need a center point and a radius, and we kind of save it in x center, y center, and radius. And when x is equal, we just assign, as I told you, the starting point is x is 0 and then y is radius, right? And then we calculate the p naught. We kind of assume that pixels are integers. So 5 by 4 is converted to 1, right? So 1 minus radius gives p naught. So we can efficiently start the algorithm and run it. And circle plot points, this is the, so as I told you, this x and y contains the, as in the diagram I told you, a single octant, right? The single octant, I told you that we are starting from a 0 comma r, and it lies on the y axis. Alright, we need to plot this line in all the quadrants. That is, a circle has 8 octants, and we need to plot this xy point in all the 8 octants. So this circle points, when we give the center point as well as the x and y, it just converts it to the other octants. Alright, so so this is going to be the only thing what we are calculating: center x plus x, y center plus y. Why do we need to add this center plus x? Yes, we need to move this point with center as our hand. So when we draw a circle using compass, we kind of keep the compass in the center and then we move around our pencil, right? So we need a point so that we can draw a circle. So x center plus x gives um, the point on y-axis. All right, so we are only calculating for this single octant. Let me change this color so that it appears more clearly. So the points which are red color is only we are calculating, and the rest is just attained by changing the sign. So these points, plot the points on all the respective octants. So that's it. Circle plot points just points a single point we are calculated, and then it finds the other 7 points. The point which appears in red color is the only point which we calculated it using this parameter p. Alright, so now let's get to the while loop. As I told you, so the while statement is, we need to repeat the steps until x is equal to greater than or equal to y. Alright, so what is the, so what is the opposite condition? X is less than y, right? So until this x is less than y, we need to kind of loop around this block. And what does this block say? Let me get this delay off. And what does this block say? We increment x for each point irrespective of the parameter, and then if parameter is less than 0, we kind of implement this function: pk plus 1 is equal to pk plus 2 x plus 1, right? And then y, we decrement y, and then here we implement the function for finding the next parameter. Pk plus 1 is equal to pk plus 2x plus 1 minus of 2y. Right, hope you understand this. So when we run this program, alright, let's check. Let me give the center point as 300 and a 300 pixels, and then 100 radius. Alright, and here we have the circle, and the red point is somewhere around here. So we kind of every time draw our graph like this. We kind of draw our graph like this, and x increments this way. X increments this way, and then here y increments. So this is our typical graph which we learn, but computer coordinate is totally different, and it is like this. X increments this way and y increments this way, and that's why we were expecting this point in the circle to be red, but it was this one. Since it kind of computer coordinate is different, we get this octant. Anyway, we can easily find out we are just calculating a single octant just by interchanging the positive to negative, and thereby interchanging x and y. We kind of find the other octants and we complete the whole circle. So this is how the circle algorithm runs, and hope you understand the circle, and see you guys on the ellipse. Thank you. One small update, and I have by mistakenly placed this pk as p0, p0, and here also I just placed it as p0, so it's actually pk, right? So this is the formula you need to remember. Thank you.
This is Code Intrust signing off. Thank you for watching. See you soon.